Hello, everyone, and welcome to class today. Our topic is hydrogen in the periodic table. All right, so we'll start with hydrogen. Cavendish is a scientist. He is regarded as the discoverer of hydrogen because he was the first in 1776 to prepare it in the pure state. He described its properties and recognized it as an element. He found that the gas was flammable, that means it burns in air to produce water. Therefore, he named it hydrogen, meaning water former. So hydrogen burns in air to produce water. Hydrogen with chemical symbol has just one electron in its shell. It therefore needs one other electron to complete its octet. Now, what to complete its octet here? So, what this means that hydrogen is has an atomic number of 1. Of course, it's the first element we come in contact with in chemistry. So, it has atomic number of 1, and therefore that means it has just one electron on its shell. Now it needs another electron to complete its duplet state. There's a term in chemistry called duplet and octet. Duplet is the ability of elements that has only the s orbital. That means to complete it, to complete it to be stable, which is one s2. That means it needs two in that. That's their first shell. That s shell is 2. Then octet is 8. So basically, what chemistry is all about is elements. You see, when chemical reaction happens, it's just elements trying to achieve the stable state, which is either 2 for just hydrogen and helium, or 8. Now, an element that has just one will readily pair with another element that is willing to give one to make it 2. And that's called duplet state. An element that has 7 electrons will readily pair with another element that is ready to give out 1 electron. That is called octet, which is 8. So basically what elements try to do is to achieve the state so that they can be stable, and this is all that leads to chemical reaction. Okay, so we move to the laboratory preparation. Hydrogen. How do we prepare hydrogen in the lab? Well, hydrogen can be prepared in the lab when certain metals react with dilute mineral acid, water, or steam. So this is when metals react with mineral acid, water, or steam. So one of them is the action of metal on an acid, and we're using zinc. When zinc reacts with hydrochloric acid, it gives us zinc chloride and liberates hydrogen gas. Another thing to notice that hydrogen exists as a diatomic molecule, meaning that and that's because it is a gas. It occurs readily as a gas, so it has to it is a diatomic molecule. That's why we have that H2. Then action of metal on water. Another way we can prepare it in the lab is reacting metals in water. So we are using sodium here, reacting with water to give us sodium hydroxide and also releasing hydrogen gas. The third method in the lab is the action of metal on steam. That's very hot water. That is already in the gaseous state. Okay, so we have iron reacting with 4 molecules of steam to give us iron oxide and hydrogen gas. All right, so we move to the industrial preparation of hydrogen. How can hydrogen be prepared in industries? Have you ever heard of batch process? That is the process with which hydrogen is produced in industry. And of course, you know that industries produce things in large quantities. So the way we produce in the lab will be different from the way that it is produced in industries. So in this process, large quantities of hydrogen are produced from cheap raw materials, namely water and coke. And why do we call them cheap raw materials? Because they are readily available. These are natural resources, water and coke. So when steam is passed over red hot coke, that is carbon, at about 1200 degrees Celsius, a mixture of carbon dioxide and hydrogen, this is known as water gas, is produced. Then this is the first process. Then after that, The excess steam is then mixed with the water gas and passed over a catalyst. This makes the reaction faster, and as a result, the carbon dioxide in the water gas is converted to carbon dioxide with a further yield of hydrogen. Here are the chemical equation illustrating that process. Alright, so we'll move to the physical properties of hydrogen. How do I know this is hydrogen when I say it? Okay, that's just without even trying to do any test. Physical, how do I know this is hydrogen gas? Hydrogen is a colorless, odorless, and tasteless gas. And when you use it to litmus paper, it is neutral. It has no effect on litmus paper. It is relatively insoluble in water. Okay, it is the slightest substance. No, it is less dense than air. It has a very low boiling point. Now we'll move to the chemical properties of hydrogen. Hydrogen is an unusual element. It has a single valence electron like the group 1 alkaline metal. Yet it is clearly a gas with non-metallic properties like the halogens in group 7. In this periodic table, however, hydrogen is placed in group 1 for convenience. Okay, so hydrogen, although it's in group 1, does not have the properties of group 1 elements. That's just what we just said. So hydrogen combines with metals to form hydrides. Hydrogen combines with hydrogen to form steam. Hydrogen combines with oxygen to form steam. Hydrogen combines directly with halogen to form halides, and also hydrogen is a strong reducing agent. Okay, to test for hydrogen, if I have an unknown substance in the test tube in a lab, how do I know the gas that is inside? So that's why we have to test for hydrogen. What you do is insert a lighted splinter into a test tube containing the unknown gas. If the gas burns with a pale blue flame with a pop sound, that means that it is hydrogen. Moreover, this experiment should be carried out only in small quantities. Now, what are the uses of hydrogen? Hydrogen is used in the manufacture of ammonia, hydrochloric acid, and methanol, other chemical products. Okay, and number two, okay, so hydrogen is also used. Okay, it's also used in the preparation of margarine because under high pressure it is placed through oils in the presence of nickel catalyst to give solid fats, which are used as margarine and in the manufacture of soaps and candle. So since hydrogen has a low density, that means it is not really heavy, it is used for filling balloons. Also, hydrogen is a constituent of many gaseous fuels such as water gas and coal gas. Liquid hydrogen is also used as rocket fuel. And we have isotopes of hydrogen. Hydrogen exists in three isotopic forms, namely hydrogen or protium. This isotope meaning that it has different mass number. The mass number is the number written up as the superscript, and they all have the same atomic number, which is 1. So we have the one that has the mass number of 1, atomic number of 1 is the regular hydrogen or protium. Then we also have the heavy hydrogen, deuterium, has a mass number of 1, atomic number of has a mass number of 2, right? The atomic number of 1. And we also have tritium, a mass number of 3, an atomic number of 1. Okay, and they all have, okay, yes, so I've explained that. So we'll move to, let's come to the end of this class. Let's move to summary. Hydrogen has just one electron and can be prepared in the laboratory by the action of water, same on mineral acids or on metals. Then with a lighted splinter, hydrogen gives a pop sound and burns with a pale blue flame. That's the test for hydrogen. Then hydrogen has 3 isotopes: protium, deuterium, and tritium. Some assignments here for you. Describe the laboratory preparation of hydrogen using chemical equation where sodium reacts with any mineral acid of your choice. How would you identify hydrogen and oxygen? With a chemical equation, show that hydrogen is a reducing agent.